Welcome to another Graphical Basic tutorial. This is part 17 for the PIC16F171 chip family. Hello, my name is Evan Venn. I'm a co-developer at Graphical Basic along with a host of other people that I want to give thanks to. So let's get into the slides and see what we're covering. What we're looking at today is the toolchain, the Graphical Basic toolchain. Well, what is Graphical Basic? It is an open source compiler for Microchip PIC, AVRs and Logic Green's AVR microcontrollers. We've extended it in terms of the libraries to support the 16F171, so it's worthwhile you understanding the toolchain that sits behind it. For today, I'm going to be doing some coding, so I've got connected the Microchip low pin cat demo board, but you can make your own by copying that onto the breadboard using the design laid out by Chris Roper from South Africa. So I've got hooked up the earth, 0 volts, or the transmit on port C.4, and you can then put any debug or output to a terminal if you wish. And we've shown you how to do that in previous tutorials. So let's go into the meat of what we're here for, the toolchain itself. Well, the toolchain itself is a compiler that was started in 2013 by Hugh Constantine. And he has put a lot of hours into this to ensure that the quality is as high as possible. And then I've taken up the mantle more recently. But what does it do? It takes your source code, the red stuff, and it integrates that with the libraries that are published through the preprocessor. The preprocessor expands your code, replaces constants, ensures that the syntax and the register bits are correct. It enables you to do calls across libraries. And it ensures it brings together the hundreds of different routines that are available to you in the libraries, plus your own creativity. It gets passed after that into a series of lists, which are called the code translator, and that is essentially starting to target your code for your target chip. It starts to take away and create the target solution for your particular chip. That might include memory mapping, labels, but not the specifics of the assembly, but the methods to get you there. So what are loops look like? How do we handle incremented numbers? How do we do mathematics? Are all very specific to a particular chip. But from your standpoint, from the source code, they've all been considered through the preprocessor. They get passed to the assembler, and the assembler generates a series of reports in terms of text files and HTML files, and then it gets passed into the linker. But at that point, it will push out an assembly file that you could actually review, and it looks like assembly as in published. It will be the Microchip or the LGT assembly listing. It then gets passed into the linker, which is held within the Graphical Basic compiler. Can't pull it apart, and it will generate the absolute machine code hex file for the particular chip. It is a single solution with inputs and outputs, but there are interfaces which I'll peel back for you very shortly. One of the tools that Hugh did and has released is Graphical Basic. It uses the compiler, it sits above it, and you can create a graphical program, a graphical representation of a source program. It gets passed into the compiler, no different from any other text editor. However, you'll have to use things like PPSTool, which you've seen, and the programmers to program things. And you'll have to lift those pieces in and out yourself. Programmers are integrated, but they're not as sophisticated as in the Windows version. But it's still an extremely useful tool for education. Things like CLC, configurable logic, they are available, but you're going to have to find those through your start menus. PSMC, another tool, you can also find that through your start menu, but they're all installed within the toolchain. Then there's the Windows IDE. I call it Windows IDE because there's more than one, and I'll explain that in a moment. You've seen one of them. You've seen GCStudio, and GCStudio is our latest release, which is a managed update program. So that means it manages your environment, it gets the latest updates, it applies them to your installation, and it includes a new editor called GC Code, and that's based upon VS Code, which is multi-platform, which is why we did it. However, it does support SynWrite or Genie, and we'll have a look at that very shortly. It integrates with the programmers. It integrates with the program editor. You've seen some of those, but we'll have a review of those very shortly. Also, there's PPSTool. There's other tools like the CLC tool, PICInfo, PSMC, the terminal. They're all integrated within the IDE so that you can access them with ease. Because how many tools do you think we've got? We've got 28 different tools, and we have to keep a list of this for regulation control. And they go through from AVR tool to AVR Dude through to Express Loader for Microchip Express boards. Some of those are code generators, some of those are programmers, some of those are converters, and some of those are IDEs. This list is available and published on the forum, and it will tell you where we can get support. So many people are involved in the maintenance of these pieces of software. But I touched on this. I'm going to come back to this diagram and walk you through it again. Explain to you, you have compiler options. And we're going to see a compiler option tomorrow in detail. But what it does, it takes your source code, libraries, pre-processes them through the code translator. It assembles or creates assembly files, pushes those out into the assembly language file. You can then pass that into a linker to generate the absolute machine code hex file, and you can use your own choice. You can use GCASM, MPLab, PKS, MPASM, etc. And you'll have seen during my tutorials that I have changed between those for the eagle-eyed. I do that for testing purposes to make sure it's okay. But this is quite useful because that means I can take a piece of code, generate it from your source code, and push it through another assembler or linker to ensure of its quality. Also, it enables me to do debugging, which we'll look at tomorrow. We have variants for Linux, BSD, and Mac. We supply programmers and programmers' advice. We provide scripts, which you'll have to find your own editor. They're in the distribution in SourceForge. So what I want to do is have a quick look at GCStudio, PICInfo, PSTool, quick look at edit preferences and how we do that code portability, and then we'll have a look at CLC. So I'm going to go out to my desktop. I'll take you with me. GCStudio. And you've seen this before, but this time we're not going to go straight into the folder, but we're actually going to take the spanner at the top. Inside of here, you have different settings. I said it was a managed environment. That's called the update channel. And you can take the mainstream distribution, no demos, dev previews, compiler only, or no updates. You select, but it will do exactly what you want. So if you want to take a snapshot, bring it down, install it to a particular folder, turn off the updates, you can do that. You can select a different IDE or editor. You can choose the old SynWrite or Genie. SynWrite is pretty well supported because we're still developing for that. Genie, all bets are off. Do what you like in that. But GC Code is what I'm using. Compiler architecture, you can select what you recover to. So if the compiler itself is 32-bit, 64-bit, if you're a developer, however, or you're developing your own add-in to the compiler, you may want to use the developer option. And then there's a whole series of different resets. You can reset the file associations, reset the whole of GCStudio, you can reset the programmer preferences, you can force an update, you can clone PICKitPlus. So there's a whole series of options you've got inside of here that are very useful. But also, you can go into programmer preferences, and we've seen that before. So let's look at programmer preferences for a moment. We've seen in here how we can select different programmers. We can drag and drop them around. But inside of here, there's a whole series of parameters that have been laid out. And they generally work for 99.99% of the environments, because these are pre-installed within your configuration. Therefore, these parameters and working folders and configurations all work. But there's other tabs. Let's look at some of the other tabs. We've looked at the compiler. We can suppress some of the logging that we see when we compile. We can have verbose mode, we can have standard mode, or we can suppress summary mode. We can put our basic source into the comments, into our assembly. We can mute banner messages. But what we can also do is choose our assembler. Here I've got the internal GCSMs selected. If you compile with for LGT, it will automatically pick GCSM, for instance. But if you wanted to go back to PICAS, you'd simply select that. And then there are tool variables, and these are variables that are used within the configuration of the parameter of the programmers, and they're used as your setup. So if you wanted to install MPLAB into a strange directory, you would actually you would tell the compiler here what that particular file was, what that particular directory was. And the same goes for PICAS. I've actually installed in the default folder, and it will keep that up to date for me. So preferences not only looks after your programmer, it looks after features of the compiler, but also some of the key tool variables that are used in your configuration. Let me go inside of, let me start PICInfo up just by going into GC code without any program. I'm just going to press F2 when it started, toggle screencast. Press F4, PICInfo. One of the tools we looked at previously is this. With the chip selected in the hundreds, thousand of chips that are available, it tells you there are some utilities, PPSTool, GCP preferences, which you've just looked at, and the IDE that you've got selected. You can also go to the data sheets, the web page, the errata, and the programming page up on the Microchip website. So if you want a quick way to find them, come into here. Then you don't have to hunt around, because this opens it up a lot quicker than you hunting around. You've seen the configuration options in here, typically the ones that you'll be choosing are the master clear and low voltage programming, wherever that is, just above it. There we go. And then you can generate a new config for your program and copy that in. But also you can get to PPSTool from here, which is extremely useful, because if your chip is not a PPS chip, let me select an older one, it's grayed out. So that tells you it is not a PPS tool, PPS chip. Therefore, you don't need to set up PPS. So you need to have an awareness of whether it's a PPS tool, because, for instance, serial will not work unless you've got PPS. And you've seen PPS in previous tutorials. We've seen the chip data. These are the parameters around the chip, some of the config options in detail if you wanted to see them, all the registers, all the bits of this chip, and all the interrupts specific to this chip. They're not always the same. Different chips have different interrupts, but Graphical Basics exposes the basic interrupt. You don't need to worry about the enable bit or the event bit, because they're managed for you automatically, or should be. If they're not, let us know. I want to look at PPSTool. So I've selected PPSTool, just loading it. And we've seen this before, where if you wanted to select a chip, 17126 is what we were working with. Let me find it. Disappear from my list, does it? I don't know where it's gone. I'm going to pick another one. It doesn't really matter because all I wanted to do is to show you that you need to ensure that you pick the right peripheral output and put it on the correct port. Add it in as you need to be, and copy it out, and it will put it in your cut and paste buffer that you can then use inside of your program. But we haven't seen all the tools. We have got a lot of tools inside of GrapCal Basic that we cannot cover within the tutorial. It's too big a subject. So let's go back to GC code and let's look at CLC. It's one of the tools we haven't had a chance to look at, but I want to have a look at it. So I'm going to open up the folder that we've been working in by pressing Control R, and here is the top of the list, the folder that I've been working in. Open up 300 using CLC. What we're going to do is review the code and then look at what it does and then come back to it. Essentially, look, I've got the same specification of chip. I've got something in PPS. We'll come back to that. We've got something, all big lump of stuff about CLC. We've got our standard constants, and then we've got a do loop. But that is it. Let's zoom in. A do loop, our constants, some code that's got CLC in it, and in it PPS. Because what is CLC? CLC is internal logic inside the microcontroller that you can take advantage of. You can trigger states, create filters, raise events from the CLC engine. That is quite clever. So if we compile this up, remembering that we have got no logic in here, no logic at all, I'm going to compile that. All I've done is set registers in PPSTool and set registers in all that CCL stuff, and we'll see what it does. I've just programmed it. You can see the board. If I push the button, the LEDs come on. So does the electric motor that's standing next to me, which is a bit scary. But you can see that when I push that, 2 electric motors also start up. So I'm going to disconnect those. There we go. Let's just disconnect it. There we go. And so how does that work? It's because the CLC is a logic tool. What I'm going to do is we're going to start up MPLAB or CLC tool, and we're going to have a look to see how it works. Let's go to my desktop. There's a tool called CLC tool. It's installed within your configuration. However, it doesn't support every chip at the moment. So I'm showing you another way to make it work. There is a tool that you can download called MPLAB code configuration. And I'm going to create a program. This is, I'll zoom in on what we can see. You'd ask for a project name. Okay, I always put it in my folder where I'm working because I might want to come back to it. So I'm going to come into my vendor boards where I've got my project sitting, and I'm going to call it new folder. I'm going to call it CLC. I'm going to select that as my folder. I'm going to create a project using the MPLAB code configurator in that folder because we're going to steal some of the source. Because, as I said, CCL tool doesn't support this chip. It may do. Let's select our PIC. PIC16F17126. There's our chip. That means it's supported. Great news. It opens it up. I'll zoom out to my desktop. It's now loading. The only option of content type is MCC melody, select it and select finish. And what it's now done is actually set up the libraries that we can actually use. You can see my CCL tool from our developers is a little bit faster than this. It's initializing the project, pulling in all the associated libraries from Microchip's development area that's on my computer, and it will eventually come up with a user interface. Great, here we go. 50% loaded, and it's called the Code Configurator Standalone. I'm using 5.117. Important things to recognize: you've got project resources, top right, top left, sorry, device resources, a view of the chip that we're actually using, the pin manager, and then you've got the builder. And we're going to be using the builder in a moment. First thing you just need to do, just to make sure that you get your configuration correct, you should always do this, is decide if you're using low voltage or high voltage programming, and I always select that because I use high voltage programming because it's a PIC too, which gives me the flexibility on the master clear. So inside of the pin manager at the bottom, I can now set the master clear as an input, which is absolutely wonderful, okay, because that's what I want it to be. But I've turned it off for the time being. There we go. CLC. Let's load CLC. Driver resources, drivers, add in CLC, CLC1. And what CLC1 does, it allows me to set up a set of configuration in terms of the logic cell that's inside of this microprocessor. And here it is. I've got a set of logic cells in here, and I can select what I want to do. I can say I want it to be an OR or XOR. I'm going to take an input called CLC1, and I'm going to knot it. And it will then come through here, and whatever the result is will be high or low at the output side over here. Well, that is it. That will configure the CLC in terms of the logic cell. What about my inputs and outputs? I'm going to have my outputs, CLC1, inside of my grid view down here. I'm going to select 0, 1, 2, and 3, because there are LEDs. And for the input side, CLC in 0, I'm going to select the master clear. Or did I select master clear? Oh, I did not select the master clear. That's RA3, which is there. So CLC output is our 4 LEDs. Our input is that reset button that we've been working with. So let's generate some code, because it's a code generator. It's generated some code for us. Cool. Let's go back into our demonstrator here. Let's look at our source code that we were looking at before. We have some PPS. I'll delete that. We have some CLC code. I'm going to delete all that, because what I'm going to do is I'm going to open up the files that have just been created by Microchip. Open up the folder CLC, MCC generated tools. There's a whole series of files here, and there's one called CLC, source, CLC1.c, and inside of here, there is the initialization. Just take the initialization and copy that lock, stock, and barrel into Great Cat Basic in the section where we had it before, which is before the loop. Great. So that's one thing we've done. We need the PPS. We should steal the PPS as well. MCC generated files. Open it up into the system. Source pins.c. Look in here for the PPS section. Don't take anything else because it's not needed. PPS registers. Copy that. Go back into your Graphical Basic source and paste it into the subroutine. Press F5. It will compile the code unchanged. It's now downloading it to the PICKit2 down to the board. I'm now going to press on here, and I've now got exactly the same operation because there is no program in here. It's codeless. CLC is using the internal code logic to provide the inputs and outputs. So you can use CLC tool. There is for other chips, you can press F4, CLC version 4 supports a lot of chips, but not every chip. Hence, I've shown you how to do in the code generator. If I show you my desktop, this is the CLC designer. It looks the same. It just doesn't support the chip that we require. So we've had to go out. If I was using a different chip, I would use exactly the same, and I could then view the code, and it will then put the code inside a small editor for me so I can copy it out. It's a lot faster, but it doesn't support it. So it's worthwhile knowing that you can always use the standalone MCC. Big subject, PowerPoint. So what I wanted to do today is show you how to use a CCL tool, which I've done. We've got some LEDs working with no CPU code. There is no CPU ticking away. It's actually going through the sleep as well, which is wonderful. So there is usefulness for CLC, and it's just down to your use case. Toolchain, we've seen that. And tomorrow we'll be looking at assembly and alternative assemblers. We will be using MPLab version 6 to take Graphical Basic source code, compiling it, programming it, and putting it into the chip, and then walking it in the debugger. And with that, we'll call it a wrap.